Okay, here we are doing page 2 of the mock exam. Okay, first problem. It asks for the inverse sign of -1. Okay, let's rewrite this as a sign because inverse sign sometimes scares people. What is the sign of what angle is equal to -1? Remember from the first page, we know that the sine of theta is equivalent to the y-coordinate of a point on the unit circle. So we're saying that the y-coordinate on the unit circle is -1. What are the points on the unit circle that have a y-coordinate of -1? Well, it turns out there's only one. There's this one, right? This point here, whose coordinates are 0, -1, is the only point on the unit circle that has a y-coordinate of -1. What is the angle that can be reached for this point? So you would have to go, if it's a positive angle, you would go from here to here. So you could say that it is 270 degrees, right? You might also say that it's -90 degrees because you can reach it from that direction. Okay, so either -270 degrees or -90 degrees is the angle that has an inverse sine of -1. Okay, let's go to the next one. The next one has inverse cosine of -√2/2. Okay, so basically what we're saying is what angle has a cosine of -√2/2? Okay, if you remember, √2/2 is the cosine of a 45-degree angle. In this case, we want the 45-degree reference angle, okay, but we want it in a direction where the cosine is negative. If the cosine is negative, that means that the x-coordinate is negative. That's what we learned in the previous page, right? So the x-coordinate is negative on this side of the unit circle. Now, -√2/2, you probably might know that it's also -0.707, okay? So -0.707 corresponds to an x-coordinate either here or here, okay? So it could be this triangle, which is 45 degrees here, or it could be this triangle, which is 45 degrees here. So since it didn't say what quadrant you're in, you could find either this angle or this angle as your answer. So the first angle would be 180 minus 45, right? 180 minus 45 is 135. So this first one answer would be 135. The second answer would be 180 plus 45, which would be 225. Okay? So there's two possible answers for this. You could put 135 degrees or 225 degrees. Okay? All right, next one. Inverse tangent of -√3/3. Let's write this as a tangent. So basically what inverse tangent of -3/3 is asking is, what is the tangent of what angle is equal to -√3/3? Okay, so in this case, let's see. I can also write this as -1/√3. It's the same thing, right? If I multiply -1/√3 times √3 over √3, I get √3/3. Okay, so they're the same thing, right? All right, -1/√3. This is a tangent of like a 30, 60, 90 triangle, either the 30-degree angle or the 60-degree angle. I can't remember which one it is. So what I'm going to do is I'm going to draw the triangle, and then I'm going to figure out which one it is, if it's 30 or 60 degrees. Okay, so I'm going to draw the triangle. I know that this triangle has, this would be 1, this would be 0.5, and this would be 0.866, also known as √3/2 for some people. Okay, and 0.5 is also known as a half to some people, right? Okay. Now what I'm going to do is I'm going to figure out the tangent of the 30-degree angle, which is the red one, and I'm going to figure out the tangent of the blue angle, which is the 60-degree angle. Okay? All right. So the tangent of the red angle would be opposite of, like it would be 1/2, right? So the tangent of 30 degrees would be 1/2 divided by √3/2. And this is equal to 1/√3. Which is equal to √3/3. Hey, what do you know? I got what I wanted. Okay, so it turns out to be it's the tangent of 30 degrees. The only thing I don't know is which quadrant I'm looking at. Okay, since it's -1/√3, it's obviously not quadrant 1. Okay, so I need now to draw a picture and I'm going to have square root of 3 over, I'm going to have a 30-degree triangle. It's going to be either this triangle, or maybe this triangle, or maybe this triangle. Let's figure out which one it is, okay? If I have, I'm going to draw a bigger picture, okay? Draw a bigger picture, and I'm going to draw this angle, this angle, this angle. These are all possibilities. And I'm going to draw reference triangles in green. Each one of these reference triangles is a 30-degree triangle. Okay? Now, I'm looking for a triangle with a negative tangent. If it's a negative tangent, that means I'm going to do a different color. A negative tangent would be opposite over adjacent, where one is negative. Either the opposite is negative or the adjacent is negative, but not both. So the x coordinate has to be negative, or the y coordinate has to be negative, but not both. Okay? So let's figure out which one it is. For this coordinate here, the x coordinate is negative and the y coordinate is positive. For this one here, both the x coordinate and the y coordinate are negative. For this one here, the x coordinate is positive and the y coordinate is negative. Okay? So, which one of these could possibly be the answer? Okay, this one or this one, right? It can't be this one, because if you have two negatives, if you divide the opposite, which is negative, by the adjacent, which is negative, you're going to get a positive number. Okay? So it can't be this one. All right? So the two possible answers are, this is a 30-degree angle, this is a 30-degree angle. So the two possible answers are 180 minus 30, or 360 minus 30. So let's write both of those answers. We're going to have 150 or 330. 150 degrees or 330 degrees. Okay. Number 5. Find the length of the arc. Okay. Now, there's a couple ways to do this. I'm going to do it the way where you don't have to memorize the formula. Okay? I know that the circumference of a circle is equal to 2 pi r. Okay? And in this case, r is 10. So I know that this circle has a circumference 2 pi times 10, which is equal to 20 pi. I'm not going to substitute 3.14 for pi yet. Now I'm going to look at this, this circle, or this arc. This arc, I can find that it is about 3/4 of the complete circle. And the way I could do that precisely is I could take the angle measure, 270 degrees, divide by the total measure of the circle, which is 360, and multiply it times 20 pi. Okay? So that would be equal to 3/4 times 20 pi, which would be equal to 15 pi. Okay? And if you would like to, put that in your calculator, 15 times 3.14, and that will give you a decimal answer. Let's find the area of a sector. The way you find the area of a sector is similar. You can find the area of the total circle, which would be pi r squared. In this case, r is 12. So the total circle would be pi 12 squared, which is equal to 144 pi. Then I'm going to find just the part that is colored in here. Okay? The part that is colored in, now I'm not sure if we're supposed to, it's this part, right? This is the sector we're looking for, right? Okay, so we're going to find this proportion. Well, it's 60 degrees for this sector. What is the total degrees? It's 360. So what I'm going to do is I'm going to take 60 degrees, divide by 360 degrees, and multiply it times 144 pi. And that'll give me the area of just this little pi piece. Get it? Pi piece? Okay. And this will give me 24 pi. Okay, and if you want to, you can put 24 pi in your calculator and figure out what that is. 24 times 3.14. All right, and that is page 2.